everybody. This is me. I'm a front-end web developer here from Belgium. And in my spare time, I like to collaborate on various open source projects, such as the HTML5 boilerplate, or JSperf, or Lodash, and many, many others. Just check out my GitHub account if you're interested in that kind of stuff. Anyway, my Twitter handle is simply my first name, as you can see. So if you happen to have any questions, just mention me on Twitter, and I'll make sure to get back to you. Now, the official title for this talk is 10 things I didn't know about HTML, but really I have more than 10 things to talk about, so we'll just have to see how much time I have. And also, I won't be limiting myself to just HTML, so this is probably a fairly more accurate title. And it will be a talk about a number of things that weren't obvious to me when I started out with these technologies. So the kind of things that surprised me when I finally did find out about them. The mind-blowing moments that some of the other talks already talked about today. So first, I'd like to take you all back to the glory days of HTML 3.2, if that's okay. Back in the day, there was no such thing as CSS yet. So the HTML standard included some presentational elements and attributes. And one of those attributes was the BG color attribute. You probably remember using this, or maybe you've played around with it for fun. It's very straightforward. You just give it a value like pink, for example, and then you get something like this, right? Of course, this is very pretty, and you can also use hexadecimal color notation. In this case, you get exactly the same pink color, except you're using hexadecimal digits to represent the color value. Now, the first thing that surprised me here, back when I was experimenting with this, is that you can actually get away with omitting the hash symbol here. So this works exactly the same way. You get exactly the same color. And browsers don't really care about this. However, they do care if you're using the shorthand notation. In that case, you have to use the hash symbol, or the browser will map it to a completely different color. Now, when you use something like F3F, like you can see here, you probably want it to map to FF33FF, because that's how it works in CSS, right? So if you forget the hash symbol here, you end up with a completely different color, because it becomes OF03OF instead. And the fun thing is that all of this is defined in the HTML5 spec. It describes the complete algorithm to parse a so-called legacy color value. So whenever a value is entered that isn't a CSS color, like pink, for example, some other rules apply to turn the string into a color of some sort. And one of those rules is that characters that are not hexadecimal digits, they basically get interpreted as if they were 0. Now, of course, if you're easily bored like me, you can use this to have a bit of geeky fun by just trying out different values. For example, you could try using your own name and see which color you map to. I also tried some other things. For example, I noticed that sick maps to green, which is kind of fitting, right? It turns out that only the C in this case is recognized because it's the only hexadecimal digit, and everything else gets interpreted as a 0, so you get 0, 0, C, 0, and then the rest of the algorithm just appends the other zeros at the end. Another funny value is if you use Mr. T, which is the actor who played B.A. Baracus in the A-Team, you end up with black. I thought that was kind of fitting as well. Also, I noticed that if you use Chuck Norris, the browser will use the blood of Chuck's enemies to render the page. I'm not making this up. This is real. I also tried some other random stuff like crap, for example. Not sure how it looks through the projector, but it's like this yellowish brown color. However, if you're Zach Holman and you're using emoji instead, you get a black background. So apparently crap is brown and poo is black. Didn't know that. I also tried to value ArrrrCamp, and for a pirate-themed conference, you would expect to get maybe a different color, one that isn't pink, purplish, perhaps. But then I noticed the hexadecimal color that it corresponds to. It spells out AOAO, right? And growing up in the 90s, this reminded me of something.
Ayo, Captain Jack! Ayo, Captain Jack! Bring me back to the railroad track! Bring me back to the railroad track!
Yeah. So anyway, it's a 90s song by a guy who calls himself Captain Jack. What are the odds, right? That's probably why they come up with the name ArrrrCamp, just so it would map to this color, I'm sure. Now, of course, nowadays you shouldn't be using the BG color attribute anymore. It's now deprecated, and it's actually invalid HTML if you use it nowadays. So let's talk a little bit about valid HTML. because when I first started out with HTML and I first found out about HTML validation, I got really excited about it, and I became crazy obsessive about validation. Now, it turned out that there are 3 layers of conformance criteria. And the first one is the DTD, or the document type definition. And it's probably the most obvious one that validators can implement. A DTD is basically a file that lists all the elements that are allowed in a given language. And then for each element, it also lists all the attributes that it accepts and where in the document it's allowed. So there's a DTD for HTML4, there's a separate DTD for XHTML1, and so on. You get the idea. So a DTD-based validator would be able to tell us that this is not valid HTML, for example, because it would know that a P element is not allowed in the head. Also, a DTD-based validator would be able to tell us that this is not valid HTML, because there is no kitchen sink element. So as you can see, a lot of common mistakes and typos maybe can be detected using nothing but DTD-based validation. However, it is unable to detect some more subtle validation errors, like the following. As you can see here, the placeholder attribute is used, but it's only really allowed for certain input types, and the date input type is not one of them. So while this may look like it is valid HTML, it's actually invalid, but the DTD wouldn't be able to detect it. Similarly, a table with an unequal number of columns for each row is also a validation error, but because you're using elements that exist and attributes that exist, the DTD-based validator wouldn't be able to detect it. So this is why a second layer of conformance criteria is needed. And these criteria cannot be expressed in a DTD, but they can still be automated or written in a program. Then finally, there's a third layer of conformance criteria, and those are the things that can only be really checked by a human. And this includes things like checking if the alt attribute for images is being used correctly, or if the text content of a time element actually represents a time, or if the content of a block quote is actually a real quote. There's no way a computer can check that stuff for you. So what I learned here is that I shouldn't be that obsessive about HTML validation, because validators can only check for 2 out of the 3 conformance criteria anyway, and validators are programs too, so they have bugs anyway. And I think it's okay to have a validation error or 2 on your page, as long as you know why it's there and what it is you're doing. For example, if you're using the XUA compatible meta tag, you can use this to trigger the latest available rendering mode in Internet Explorer, and that's very useful functionality. However, as soon as you add it to your HTML page, a validator will complain about it because it's not valid code. But does that matter? Well, if you asked me 10 years ago, I would have said yes, but nowadays I don't think so anymore. So use validation as a tool and not as a goal. Now, another thing I learned, it has to do with character reference or HTML entities. As you probably know, character references start with the ampersand symbol. So whenever you want to use the raw ampersand symbol, for example, you can escape it by using ampersand AMP semicolon. And now the semicolon here marks the end of the character reference. And scientific research indicates that the semicolon is probably the most dangerous form of punctuation in the history of programming. Ruby programmers probably don't know what I'm talking about now, but if you ever write JavaScript or even CSS or HTML, you'll probably understand why semicolons can be a huge pain in the ass. And here's an example of that. At some point, the JavaScript used in Twitter's Bootstrap was missing an optional semicolon. And this didn't actually cause any problems until you try to minify the file using a specific JavaScript minifier, because that JavaScript minifier would just throw an error and explode, kind of. So someone helpfully filed an issue, and then the owners of the repository said, okay, this is not a bug in our code, this is a bug in the JavaScript minifier that you're using, and they closed the issue. And then the author of the JavaScript minifier chimed in, and he said, and I'm quoting here, "That is insanely stupid code. I'm not going to dumb down JSmin, or my minifier, for this case." Needless to say, it was a bit of a shitstorm afterwards. There were over 280 comments, and all they were arguing about in the end was just this single friggin' semicolon. So I think the problem with semicolons in general is that in many languages they appear to be optional, but in reality they're not. So, and one of the things I learned is that this actually applies to HTML as well. So getting back to our code example, turns out that we can actually omit the semicolon here, and everything will still work, but the code will become invalid. And now you know how I feel about HTML validation, but if the only thing keeping you from having a valid HTML page is this single semicolon, maybe you should just add it. Also, another reason not to use this kind of trick is if you use it as part of an attribute value, you'll see that it leads to different results than what you would expect. As you can see, the title attribute is parsed differently as the text content of the P element in this case, which is very confusing. So just don't do this. But the real surprise for me was, in this case, that in some situations, you don't even need to escape the ampersand character at all. In this case, for example, it's followed by a whitespace character, so you can get away with simply not escaping it at all. It's still valid HTML, and it works reliably in every browser. It was a bit of a mind-blowing moment for me. I'm going to spare you the gory details, but if you're interested in that, check out the URL at the bottom of the slide here. Another example is the greater than symbol. As you know, it has a special meaning in HTML because we use it to close open tags, right? So whenever you want to use a raw character, you can escape it as ampersand GT semicolon. Now, the same thing applies here. You can actually get away with omitting the semicolon in this case, although it's still a very bad idea. Also because if you use it as part of an attribute value, again, you run into the same issue as before. Now, again, the real surprise for me was that this character even can be used unescaped. And the reason for that is that its only purpose is to close tags. So unless the browser is currently parsing an open tag, it's pretty obvious that just the raw symbol should be used. In fact, the only situation in which you have to escape this symbol in HTML is if you're using it as part of an unquoted attribute value. In all other cases, it's not really necessary. Now that we're on the subject of tags and elements in HTML, I'd like to show you this small, simple HTML document. I'm using the HTML5 doc type here, but what I'm about to say applies to HTML4 and even HTML2 as well. So you can probably see the HTML and the head and the body elements there. Well, it turns out that you can actually omit their and tags. They're completely optional, so you can just remove them, and then you end up with this document. And this will still valid HTML code, and it still works reliably in all browsers. I remember when I found out about this, I was so excited. But then it gets even better, because it turns out that you can even omit their star tags for these elements as well. And then you end up with this document that is super minimal. It only contains a doc type, a title, and maybe some content. And this is as minimal as it gets, pretty much. And in this case, the browser will still automatically generate the HTML and the head and the body elements in the DOM. So you will still be able to use CSS to style them or use JavaScript to interact with them. Now, on that note, this is probably the most useless tutu ever. I mean, if you're going to get an HTML tutu, at least pick some tags that aren't optional or implied. You know. And also, this tweet, of course, I'm taking this completely out of context, but this tweet is rather misinformed. It says HTML and head and body is all the HTML you ever really need. Well, here's the fixed version, because he actually listed all the tags that you never really need. What you do need is a doc type, he didn't list that, and a title element as well. Oh well. So that minimal HTML document that I showed you just got me thinking, how far can we take this? How minimal can it get, really? So I decided to create this document. Now, it looks fairly simple, right? It's probably some HTML with the text in there, and then some very basic CSS to add the borders and change the font size and stuff like that. However, if you look at the source code of this file, you'll see that it's completely empty. So what is going on here? Well, as you can see, the content length for this response is actually 0, so I'm not cheating there. There's no special trick going on. The trick is that I'm using the link HTTP header. And this is kind of a replacement for the link element in HTML. Of course, it only works in browsers that support it, and at the moment, that's only Firefox. Older versions of Opera have supported it for a long time, but since they switched to Blink, it doesn't work anymore. So if you try this demo, be sure to open it in Firefox. So basically, this gives us a completely empty HTML document that still gets a CSS file applied to it. So the next step is simply to make the document look like it contains some actual text. So for this, I used the CSS content property, as you can see there. I applied it to a pseudo element on the body element. It's not really necessary to use the after pseudo element for this. It should be able to work on body, but Firefox doesn't support that, so that's why I did that. So I thought that was kind of a neat hack. It's a completely empty HTML file, but it still looks like it has content and CSS and everything. Another thing I learned some stuff about is font family names in CSS. And for a long time, I always quoted my font family names whenever they would include white space. And I think this was inspired by the warning messages that the CSS validator would throw at me whenever I was doing it. So whenever there was white space in the font family name, I figured it must be quoted. However, I later learned that this is not really the case. Whenever the font family name is a space-separated set of CSS identifiers, no quotes are needed at all. And in fact, spaces aren't really problematic at all. There are many other things that are much more dangerous in font family names. For example, if you have a font named 456 Beria Street, now, because this font family name starts with a digit, it's not a valid CSS identifier, so this code won't actually work. The rule will silently be ignored. Now, you could make it work by escaping the first digit, and that will look something like this, but of course this looks a little bit messy and confusing, because instead of 456, it now says 3456, and there's this weird space, and there's a backslash, and oh my god, what's going on? So another way to fix this is just to add quotes to it. So I'd say whenever you're in doubt, always just use quotes. It avoids a lot of problems, but there is no need to use quotes just because there's a space in the font family name. I also made a tool for this, so you can enter any font family name you want in there, and it will tell you if it would make sense to use quotes or not. I know it's not something you would use every day, but still, I had a lot of fun making it, so there. Now let's take a closer look at attribute values in HTML and in CSS. As you can see, in both HTML and CSS, we can use quotes around attribute values. I hope this is not something new for any of you. In some cases, like in this example, we can simply omit those quotes and get away with it. It's still valid HTML, it's still valid CSS, and everything still works exactly the same way as in the previous slide. However, it's important to note that the rules for unquoted attributes are different in CSS than they are in HTML. So in this example, the HTML is perfectly valid, but the CSS won't actually work or validate. So the solution, of course, in that case is to just use quotes. So for this reason, I'd say it's probably best to just always quote your attribute values, especially when you're in doubt. Now, I've made another tool for those people who prefer not to use quotes whenever they can get away with it. You can just enter a value here, and it will immediately tell you whether it can be used as an unquoted attribute value in HTML and in CSS. And as you can see, sometimes the result for these two languages is different. Another thing that surprised me is how JavaScript handles characters in strings. So for example, how would you count the number of characters in a string? It seems pretty simple, right? My first thought would be to use the length property of the string. So as you can see here, in these examples, the length property just happens to reflect the number of characters in the string. But what I later found out, and what really surprised me, is that this is not always the case. There are characters that actually have a length of 2 in JavaScript. And the reason for that is that JavaScript uses this thing called surrogate pairs to represent symbols outside of the basic multilingual plane in Unicode. Of course, this is a huge pain to deal with because we're all humans and we want to think in terms of Unicode symbols or Unicode characters, and we don't want to deal with this surrogate pair bullshit, but unfortunately we have to. There are even formulas that determine how these surrogates are being calculated, and here's the JavaScript implementation of that. I don't want you to remember this or anything, but the point is, if you want to do something as simple as counting the number of symbols in a string, you basically need to know all of this just to do it right. And that's a bit of a pain, right? So an example solution for that is to use the Unicode.js JavaScript library. It has this helper methods called UCS2decode. You can just pass it a string, and then it will return an array of code points. So it will only contain a single element in the array for each symbol. So afterwards, you can just get the length of that array, and then it will have a more accurate result, as you can see here. Now, for a long time, I've wondered what symbols were allowed in JavaScript variable names. And it turns out that it's not very straightforward at all. So rather than trying to explain all of it to you, I made this little quiz here. Which of these crazy variable names is invalid? Who thinks it's the first one? No one? Okay, so some people there. Who thinks it's the second one? Who thinks it's the third one? Who thinks it's the fourth one? Well, let's take a look. Turns out it's the last one. You know why? There's a zero width non-breaking space right here. Yeah, but just to help you out, here's a handy regular expression that you can use to remember all the rules for valid variable names in JavaScript. It's literally over 9,000 characters long. This is according to ECMAScript 5.1 and Unicode 6.3. It goes on like that for another while. Yeah, so I hope you're taking notes of this, because yeah, there we are. So if you don't want to memorize this, you can always use another useless tool that I created. You can just enter any string in there, and it will tell you if it's a valid variable name or not. Now, this may seem a bit silly, but it actually helped me find bugs in pretty much every major JavaScript engine out there. So it has its uses, I guess. Now, let's talk about truthy and falsy values in JavaScript. Of course, it's important to know which values are truthy and falsy because you're dealing with those concepts all the time. For example, if you're using an if statement. And the specification defines this algorithm that maps values to true or false, basically. So as you can see, undefined and null are both falsy. Booleans are just the same as the input. If it's true, it's truthy. If it's false, it's falsy. Makes sense, right? Then positive 0, negative 0, and not a number are falsy, and every other number is truthy. Empty strings are falsy, but every other string is truthy. And then finally, and this is the important part here, all objects are truthy. So even if it's an empty object literal or an empty array, it will still be truthy. Now, of course, as it goes with the web, there is one exception to this rule, and it's in the DOM in this case. Does anyone know what I'm talking about here? It's actually document.all. This is an HTML collection that contains a list of all the HTML elements on the page. But if you check it out, it's actually falsy instead of truthy, even though it's an object. So why has this been done? Well, it's actually a willful violation of the spec for backwards compatibility reasons. It turns out that there's a lot of existing code on the web that looks something like this. And as you can see, it checks for the presence of document.all first, and then it ends up in a code fork for that path. And if not, it just falls back to document.getElementById. Now, of course, modern browsers, they have to implement document.all for legacy reasons, but they would prefer to end up in the code path with document.getElementById instead. So the only way to make that happen without breaking a lot of code is by making document.all be falsy instead. That's why they changed it. Yeah. Now, at this moment, there's another session going on benchmarking in Ruby, so I decided to talk a little bit about benchmarking in JavaScript. So whenever you want to find out how long it takes to execute a certain piece of code, you can always benchmark it, of course, and there are various techniques that you can use for that. And the most obvious, or maybe the most naive technique that you can use is the following. You simply take that piece of code and repeat it a predefined number of times. You start the timer before that, you stop the timer after that, you get the difference, and that way you have an idea of how long it takes to execute that code snippet. Now, the problem with this approach is that devices and engines get faster all the time. So any code that you write with this pattern today will be probably useless in 5 or 10 years, because by then it will have a result of 0 milliseconds, which is essentially useless. So a slightly better way to deal with this is by doing the following. You simply keep on running test code for at least a second, and you keep track of how many times it ran in total. And then afterwards, you can easily calculate how long each run of the test code took, or how many runs per second were allowed, for example. And this is a pattern that is being used in the Dromeo benchmark suite and also in the V8 benchmark suite, so it should be pretty good. But even with this pattern, there are still some other problems. For example, Windows XP's internal system clock only gets updated every 10 or 15 milliseconds. And whether it's 10 or 15 depends on the exact system configuration. So it's very hard to tell. And older browsers like Firefox 2 or any version of Internet Explorer basically relies on the internal operating system timers. So whenever you use new date.getTime in JavaScript, it would just fetch a timestamp directly from the operating system. Of course, if you're benchmarking in such an environment, you will get a lot of inaccurate results. For example, if you have a test that only takes 2 milliseconds to run, it will give you a result of either 0 milliseconds or 15 milliseconds, and neither of those results is really accurate. So the problem is that the margin of error is way too high for these results, so we will need to work around that as well. Now, one way to do that is by using a JavaScript library called benchmark.js. It is capable of detecting various timers, and it doesn't only detect them, but it actually tests them out before it decides which one to use. See, the most commonly used timer is probably the simple newDate.getTime in JavaScript, which has a millisecond resolution, but there are various alternatives as well. In Chrome, if you start Chrome with a certain flag, you get an extra object called chrome.interval, and you can use that to get microsecond resolution. Or you can use Performance Now nowadays, which basically does the same thing. For older versions of Node, you can install an optional microtime module, which basically adds bindings, so you get a microsecond timer in Node as well. However, more recent versions of Node have a built-in high-resolution timer that goes all the way up to the nanoseconds, so that's very high precision. And finally, there's a really neat hack that kind of blew my mind when I found out about it. There's a way to get a nanosecond timer in the browser. And you can actually insert a Java applet, just like in the 90s, into your page, and then expose Java's nanosecond timer to JavaScript. And after that, you can just roll with it and use it in JavaScript. I thought that was pretty clever. Now, another thing that benchmark.js does is it performs statistical analysis of the results. So after running a test, you can be sure that the results are statistically sound. And this means, in practice, that whenever you run the same test twice on the same hardware with the same settings and the same circumstances, the same everything, it will give you approximately the same result. It should never tell you that your own computer suddenly became faster than itself or something. And that may sound very obvious, but a lot of the big browser benchmarks don't do this very well, and they have this problem. Benchmark.js is used in RoboHornet, which is a community benchmark which was started by Google. And it's also used on JSPerf, one of the projects I've worked on the past few years. JSPerf kind of looks like this. It basically gives you a really simple interface where you can just enter various JavaScript snippets. This is a very silly benchmark, but it's just an example, of course. And it generates this HTML page for you. You can copy and paste the URL and run the tests in any browser you care about. We made sure that it works even in IE6, Firefox 2. We even tested on the Nintendo DS browser to make sure it works there as well. So if you want to run benchmarks there, go ahead. And then it collects all the results as well. So once you're done running the test on all the devices you care about, you can just get the overview in one nice little table or a chart, if you will. So that's JSPerf. Check it out if you like. And that's it from me. Thank you.